Imagine a colossal group played by a perpetual number of stars, planets, and moons, all playing together superbly. At any rate, there is one explicit portion of this ensemble that has dumbfounded space specialists for a seriously lengthy time span. Exoplanets are customary planets that exist outside our planetary framework, hidden away somewhere deep in the Milky Way. You might be surprised to find that among the huge number of cosmic objects, there are exoplanets so like Earth, so tantalizingly similar yet perplexing, that they might be our planet's heavenly twin. We plunge into the charming area of Proxima b, found just 4.2 light-years away. The James Webb Space Telescope is revolutionizing our quest to understand these heavenly mysteries. Imagine a moment when your mind ventures across the gigantic, enormous space of our reality. The Milky Way, which is home to more than a quadrillion exoplanets. That is a number with 15 zeros. To put this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We would have enough to create another landmark on Earth. An excellent Gulch 2.0 that would stretch for a significant distance. What's most shocking is that around 20% of these sublime bodies have been designated as Earth-like in terms of geography and atmospheric structure. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites like our moon, trapped in gravitational dances with their parent planets. If you were to ponder finding another body in space that harbors life or could do so, the universe offers a flood of opportunities. Since we have spread out the material on an incomprehensible scale, it's time to introduce the master craftsman prepared to paint its intricate nuances, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its amplified central lens and customizable focal points, surpasses even the most advanced optical instruments. We're not just talking about any lens. Its 6.5-meter primary mirror is 2.7 times larger than Hubble's. Imagine the incredible detail it can detect, even in the faintest glimmer of a star billions of light-years away. It doesn't just see. It analyzes and examines surrounding planets. What makes the James Webb Telescope revolutionary isn't just its seeing power but also its advanced technology, including sophisticated sensors and spectrographs. These tools do far more than observe. They analyze and filter the unique light signatures emitted or reflected by celestial objects. They decode their chemical makeup, density, and even mass, acting like a space scientist. The James Webb Telescope can determine if a planet has water, organic compounds, or even oxygen. Its ability to answer such questions elevates it from a mere observer to a scientific genius. It's not just an improvement over its predecessor, Hubble. It's more akin to a quantum leap. If Hubble's discoveries amazed you, prepare for a genuine celebration of cosmic revelations. As we expand our gaze across the intricate landscape of the universe, it's worth focusing on one specific star in the celestial symphony, Proxima b. Since its discovery in 2016, this mysterious planet has stood out as a Shakespearean legend, filled with complexity and contradictions, stunning astronomers and anthropologists alike. What's the deal with all the excitement? First of all, Proxima b is practically in our galactic neighborhood, 4.2 light-years from Earth. To put it in context, if you could surpass the universal speed limit and travel at the speed of light, you'd arrive in a little more than 4 years. About the same amount of time it takes for your favorite TV show to fall into reruns. But let's delve deeper into why this proximity is so significant. We're talking about a universe that spans more than 93 billion light-years from one end to the other. So finding a planet so close and so promising for scientific exploration is like finding a gem in a mountain the size of Everest. A gem that potentially holds secrets about life itself. In the grand tapestry of the universe, Proxima b is a vibrant thread, offering us profound clues that could redefine our understanding of habitability and life beyond Earth. It's not just Proxima b's closeness to Earth that excites researchers, but also the tantalizing signs that this planet is not just Earth-like but potentially Earth 2.0. Proxima b sits comfortably in what astronomers call the habitable zone of its parent star, where conditions are neither too hot nor too cold, just right for liquid water to exist. Imagine waterfalls, wandering streams, vast lakes, and possibly oceans as deep and mysterious as the Mariana Trench. But before we start dreaming about life on Proxima b, let's consider a few of its peculiarities. For instance, a single day on this fascinating exoplanet lasts an astonishing 11 Earth days. Imagine sunrises that usher in not just a new day but unfold so slowly they resist giving way to noon, and sunsets that linger, creating golden hours photographers long for. While it sounds idyllic, it also has significant implications for its climate and habitability. How would human biorhythms adapt to Proxima b's unique light and dark cycles? Would we eat 3 or 4 times as much in a single day? Would we sleep the same way? On this entirely different world, the basic patterns of life as we know them would be tantalizingly similar yet frustratingly unfamiliar. Perhaps nature is presenting us with a riddle wrapped in a mystery, challenging our understanding of what makes a planet habitable. You might wonder how we can gather precise and reliable data about a world we've never visited. The James Webb Space Telescope, with all its capabilities, acts like a giant Swiss Army knife in the vacuum of space. It's more than a telescope. It's a sophisticated laboratory orbiting the cosmos. Using advanced spectrographs, the Webb telescope analyzes the light emitted and reflected by these distant planets. Each element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By studying these patterns, scientists can perform a remote biopsy of celestial bodies, determining atmospheric pressure and density, as well as the possible presence of compounds essential for life, such as water, organic carbon molecules, and even oxygen. This isn't just astronomy, it's space forensics. Instead of passively waiting for signs to come to us, we actively seek them, investigating the atoms and molecules of distant worlds. Particles that make up these perplexing universes. The Webb telescope isn't just an eye overhead, but an exceptionally specific examination lab, specialist, and enormous detective all in one. It allows us to transform our hypotheses about alien worlds into strategies to verify or refute them, revolutionizing our understanding of what could exist beyond our blue speck. Just when you thought you'd uncovered the most stunning layers of this galactic onion, the story takes an unexpected turn. Much like a science fiction thriller, researchers using the James Webb Space Telescope discovered something striking from Proxima b. A transmission so extraordinary that it spread through academic circles and social media. Named as a potential technosignature, it was an electromagnetic emission so intricate and meticulously designed that it hinted at the presence of an advanced civilization. The collective heartbeat of humanity seemed to pause at the height of a discovery that promised to reshape our understanding of reality. Could this transmission be the definitive proof that we are not alone in the universe? And just as quickly as it appeared, the transmission vanished without a trace, leaving behind a profound silence and a maze of unanswered questions. Was it merely a fleeting cosmic anomaly, a coincidence of celestial alignment, or something more deliberate? Could it be a coded message or a sign of extraterrestrial intelligence? The singular event cast a shadow of mystery over Proxima b, igniting fierce debates and speculation. Was it simply a passing oddity, or was it part of a much larger, more complex narrative? Yet, the story of our cosmic exploration is far from over. The ink is not yet dry, and new chapters are still being written. This time, it's not just conventional scientists but also Harvard researchers leading a paradigm shift in the search for extraterrestrial life. They aren't content with merely investigating the transmission and anomalies we've discussed. They are raising the stakes by transforming the James Webb Space Telescope into a sort of giant night vision telescope. Their goal is to search for artificial light sources in both the dark and illuminated areas of distant worlds. Imagine the incredible possibilities. Detecting natural equivalents of cities glowing in the dark, like bright SPS, solar power satellites. Envision seeing the radiant beams of light that could signify a city bustling with the presence of an advanced civilization, emitting its glow into the vast cosmic oceans. As we continue to unravel the mysteries of the universe, the journey for extraterrestrial life takes on new dimensions. Beyond the immediate intrigue of Proxima b, our grand quest delves deeper into vast, unexplored regions of space. This pursuit is driven by both technological advancements and a profound curiosity about our place in the cosmos. Ongoing breakthroughs in astronomy and space exploration have led to the discovery of numerous exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biosignature detectors, and ground-based observatories have expanded our ability to identify and study these distant worlds. One particularly fascinating area of study is the search for biosignatures, signs of life. These could include atmospheric gases such as methane or carbon dioxide, which, under the right conditions, could suggest biological processes. The JWST's capabilities extend beyond simple detection. Its advanced instruments can measure the atmospheric composition of exoplanets with remarkable precision. By studying starlight filtered through an exoplanet's atmosphere, scientists can identify chemical markers indicative of life. For example, the presence of water vapor alongside other key molecules, such as oxygen or ozone, could signal the potential for life-supporting conditions. Another avenue of investigation involves studying the climates of these distant worlds. Climate models based on data from the JWST can help predict whether an exoplanet's conditions could support liquid water. This is crucial because water is considered a fundamental ingredient for life as we know it. Scientists are particularly interested in planets located in the habitable zone of their parent stars, where temperatures could allow for stable liquid water. The search also extends to the moons of exoplanets. Some of these moons, especially those in the habitable zones of their host planets, could have conditions conducive to life. For instance, icy moons in our own solar system, like Europa and Enceladus, are thought to harbor subsurface oceans beneath their frozen crusts. Similarly, moons orbiting exoplanets could present comparable conditions where life might exist. Furthermore, the concept of technosignatures has gained traction. These are signs of advanced civilizations that may be detectable through artificial structures or technologies. This could include megastructures like Dyson spheres, hypothetical constructs designed to capture a star's energy, or unusual patterns in radio transmissions. As we refine our global collaborations and observational techniques, the search for technosignatures could uncover evidence of extraterrestrial intelligence. In addition to technological advancements, international cooperation plays a crucial role in the search for extraterrestrial life. Collaborations between space agencies, research institutions, and private companies enhance our ability to explore space. For example, missions to Mars and other celestial bodies involve contributions from multiple nations, pooling resources and expertise to achieve shared goals. Public engagement and education are also essential aspects of this mission. The excitement surrounding space exploration inspires the next generation of scientists and engineers. Outreach programs and educational initiatives help foster interest in STEM fields and encourage young people to pursue careers in space science. The development of new technologies also contributes to our understanding of the universe. Advances in telescope design, data processing, and computational models improve our ability to detect and analyze distant exoplanets. For instance, next-generation space telescopes like the planned Extremely Large Telescope (ELT) and the Habitable Exoplanet Observatory (HABEX) are poised to provide even more detailed observations and deeper insights into the potential habitability of exoplanets. As we push the boundaries of our knowledge, each new discovery raises further questions and areas for exploration. The search for extraterrestrial life is not just about finding alien civilizations but also about understanding the origins and potential diversity of life in the universe. It challenges our perceptions and expands our understanding of what it means to exist as a species. The exploration of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With every step, we edge closer to answering some of humanity's most profound questions. As we continue to explore the cosmos, the possibilities for discovering new forms of life and understanding our place in the universe remain boundless.